Okay, good morning, student. Today we start with our high performance computing subject. So, related to this subject, uh, the university will be allocated 4 hours per week. Also, we have a practical session for that one. So, it include the examination of 100 marks, which mid-term submission, mid-semester exam, that is in same exam is 30 marks, and end sem with a theory 70 marks. So basically, when we start with this subject, the first unit is considered with a introduction to the parallel computing. So this totally subject is related with the serial to parallel communication, or whatever the parameter we convert uh, serial to parallel computing. What is the benefit of parallel computation, and how can it will be utilized for the that one. So considering with outcome, after the completion of this subject, we understand the various parallel uh, concept, then design and development of effective parallel algorithm to solve given the problem, then illustrate the data communication operation on various parallel architecture, analyze and measuring the performance of modern parallel computing system, applying the CUDA architecture for parallel computing, and analyze the performance of HPC application. So overall, we observe that whatever the parallel computing that concepts they try to explain, and there with their applications, and how can be implemented. Also in practical, we learn about the some parallel algorithm, how the we can work on that one. So first unit is concerned with a introduction to parallel computing. It consists of the uh, motivating the parallelism, why we go for the parallelism, then modern processor, that is a store programming computer architecture, general purpose cache based microprocessor architecture, then parallel programming platform, which are the platform will be available for the plagiarism, uh, that is implicit plagiarism. Related with that concept, we clear the physical organization of parallel platform, communication cost in parallel mechanism, level of parallelism, that also we understand, and some of the mode of parallelism, that is SIMD, MIMD, SIMT, SPMD, then data flow models, some demands drive computation, then architecture, n-wide super scalar architecture, multi-core and multi-threading. That concept we learn in this subject. Uh, Considering this parameter, just we start with a basic concept of plagiarism. Just a second. Uh, so considering with starting with information of parallel computing, that is the first unit related with this parameter. Uh, just Om, it is visible. Screen is visible. Om. Om. So first unit is related with it. Why we going with the parallelism? So the motivation of program is clear that the root of parallelism is accelerating the computing speed has been recorded from several decades. The scalable performance and lower cost of parallel platform is reflected in the wide variety of applications. Developing the parallel hardware and software has traditionally has been time and effective intensive. If one is to be a view this, the context of rapidly improving the uniprocessing speed to be a template and question of the need. So whatever is he say that, just look out this diagram. What will be a concept of this parallel computing? Uh, So the whatever the problem we given, we divide into a number of tasks. So these lines indicate the number of tasks. So we say that this task is nothing but a instruction. Then this each instruction is given to the separate processor, that is CPU, central processing unit. So just look out what will be a happen and what will be a do. Suppose same like that we have a number of tasks is like that. Suppose we make a group of tasks look like this one. So task 1, task 2, task 3, task 4, task 5 and task 6, right? So if these tasks are go serially, executed one by one, and it is given only one processor, right? Will be a, suppose we say that CPU. So what will be happen? After the one task completion by the CPU, the second task will be a start, right? After the second task completion, then third task will be a start. After third task completion, the fourth task will be a start. So what we say that in serial computing, we require more time to execute the all the program or whatever the problem will be given and whatever the group of tasks given, it require more time, and single processor will be handle the all the tasks. So whatever the load on that single processor, it will be a increase. So what we say that the execution time and the efficiency of that processor will be a decrease. Second, the delay to execute the total program or total problem, it require more in a serial communication because of it handle one by one task. But compared to this one, so just look out this a concept. So whatever the problem we have, we divide into a n number of tasks, right? Just look out that we divide into a n number of tasks or one n number of instructions, right? And this each instruction we given separately to the each processor. We use the number of processor in parallelism. So this one processor which handle this seven tasks, this second processor which handle the seven tasks, this processor which handle the seven tasks. So what will be happen? Total number of tasks is a, suppose we say that 21. So 7 will be handled by this one, 7 will be handled by this one, and 7 will be handled this one. So at a time, three tasks are executed by uh, three different processors. So execution of number of instruction will be a work simultaneously. So processing time will be a require very less compared to the serial communication, and the load upon the processor will be a decrease. And at the same time, there are three different tasks and three different application will be a work. So that is the benefiction of the parallel computing compared to the central processing unit. Whatever the serial computing. In serial computing, what will be happen? One by one task will be a work. So the second task will be a wait. Still the first task will be a completed, and it is will till the completion of first one, and then the processor will be handle each one. So load on the single processor will be increased. Also the delay of the execution of each instruction or each task will be increasing. So that goes to be a require more time of computing and handling the number of program at a time. Only a single program will be handled. Nowadays we know that our smart device which will be having more core. So more core means we have a more processor on that one. 4 core, 8 core, 12 core. So what is the core? So it contains number of processor. So each processor will be handle separate tasks. So number of program will be a work separately, and execution time will be a increase. Plus the handling capacity of that processor will be a increase. That concept will be a include in a parallel computing, right? So parallel computing is, just look out, the parallel computing is the simultaneous use of multiple computer resources to resolve a computational problem, right? We use a group of computers or group of CPU which can be handle the number of tasks. to be run using multiple CPUs. A problem is broken into a discrete part that can be solved concurrently. Each part is further broken down to a several series of instructions. The instruction from each port executed simultaneously on the direct CPU. Right? So just look out, same thing will be clear here. So whatever the problem, that is a group of tasks, or we say that group of instruction which divide into a number of instruction depend upon how much core. Suppose this is a 3 core processor, so it have a 3 CPU. If it is a 4 core processor, it is a have a 4 processor. So total number of problem, number of tasks are divided into a number of process. So what will be a dividing by this one? All the program, all the instruction will be a work simultaneously. So execution time period will be a very less. Is it clear? What is a parallel computing? Is it clear? What is a parallel computing?
Yes, sir.
So that concept will be a clearing about the parallel computing. Just a second, I remove this one. So considering this one parameter we learn about that one. Second is the Morse law. That is one law which concerned with the concept with the parallel computing. So what is Morse law will be a say. The complexity for minimum component cost has increased at the rate of roughly a factor of 2 per year. What is the meaning of this? Look out that the complexity for minimum component cost has increased at the rate of roughly a factor of 2 per year. What is the meaning of that? Suppose we use a multiple hardware in serial communication. What we doing? We using a single processor which handle a single instruction. If we want to be increase the number of system, the requirement of component year by year it will be a double. So what we want to be a number of tasks will be handled by a single processor. Single system is like we have a multi-core. So multi-core processor means your whatever the smart device which have a multiple processor in a single core, in a single your system which can handle the 4 program at a time. So what is the meaning of 4 central processing unit not be required, only single processor will be required which handle the number of instruction at the same time. So requirement of hardware component will be a less compared to the serial computing. So say Moore's law say that if you use a single processor for a single task, for multiple tasks we require multiple processor. So meaning of that much number of hardware component will be increased. And now daily year by year it is a twice. So we try to reduce the hardware component by using a multi-core concept, by using a parallel computing. We handle a single processor with a multiple tasks. So that parameter will be said by the this Morse law. So Morse law is very important point, and exam point they ask short note on the Morse law with one of the example. Suppose they asking the Morse law, you explain this statement. The complexity for minimal component cost has increased at the rate of roughly a factor of 2 per, or certainly over the short terms this rate can be expected to continue, not to be a increase. So we try to that number of hardware parameter will be userless. A single processor which can be handle multiple components or multiple programs. Meaning of just example. Now you are using a smart mobile phone which can work number of application at the same time. We can work 4 to 5 application at the same time. WhatsApp is on, your YouTube is on, browsing also on, one of the gaming application is on. So all this program work at the same time by your single processor, which present in your mobile. So that concept we require to reduce the hardware. So that time you explain Moore's law and the diagram of this one, this parallel computing, how we reduce the hardware. By this way, we try to reduce the hardware, whatever that. So single processor which contain the multiple CPU and which handle the multiple program. So we say that suppose this is your mobile which contain three core processor which handle the three program. Three instruction means three program at a same time. That concept will be clear. So next parameter is related with a store program computer architecture. So basically, this is the architecture. We say that how the processing will be executed in your any processor. So just look out this diagram. Just I make a pencil. Sorry, pencil. Okay, right. So just look out that the central processing unit, which contain two parameters. One is the control unit, and second is the arithmetic logical unit. First is a control unit and second is a arithmetic and logical unit. Second part is a memory. It is an important parameter and which consists of all RAM and ROM parameter also. And next is the input output your devices. Whatever instruction we taking, input taking, and whatever we provide the output. So store program is which have a capability storing the your data with some of the controlling. So in control, it CPU contain central processing unit contain control unit and arithmetic and logical unit which execute the arithmetic and logical program with some of the memory which handle the input output parameter. So that is a basic concept. They say that how a computer having the architecture for storing the your data. So just go with the instruction are number that are stored as in a memory. Whatever instruction we taking from input, that will be a store on a memory. Store on a memory. Next, uh, the instruction are read and executed by a control unit. A separate architecture and logical unit is responsible for actual computing and manipulating the data stored in a memory along with the instruction. So what we say that the instruction will be coming from input which will be a store memory and how to be executed and which operation will be done, that will be done by the control unit. So control unit will be with the help of this arithmetic and logical unit, it take a decision and make the handling the instruction. So input output facilities enable the communication with user and control and arithmetic unit together with the appropriate interfacing to memory. The input or output called the control processing unit, that is the CPU. So just basic instruction how the process will be there. So we take the instruction from input is stored in memory. The control unit having a capability which operation to be executed, which operation to be executed with the help of arithmetic and logical decision. When input is coming, data will be stored in memory by control unit. If we make suppose addition of two number a plus b, so the arithmetic and logic unit will be do the operation and that will be provide to the output. So simple architecture how the process will be executed in store programming computer architecture. Just simple introduction of your parameter. That concept will be clear here. Is it clear? Is it clear to everyone? What is the store program computer architecture? Is it clear?
Yes, sir.
Yeah. So just it is a concept how we can store the data into a memory and how the arithmetic and logical unit will be execute the program with the help of control unit and how it will be provided to the just like a output. Just a second. So we go with the programming of storing the program, the computer amount of modify, and it can be changed. So it here we observe that a single processor which can be execute the arithmetic and logical unit. Just a second. So next is concept related with the. So first, what we observe that general a single processing unit what will be a do. That concept will be clear in that one. The second is a general purpose cache-based microprocessor architecture. That is a famous question in exam point of view. Most of the exam, whatever the previously conducted exam by the university, they ask about the general purpose cache-based microprocessor architecture. So what will be happen here? So they try to that whatever a single processor will be a go with a multiple processor and how the capacity of execution of number of instruction will be a increase. So that parameter will be a consider here in cache. So they say that cache based microprocessor that is important parameter related with the our. We know the processor. We just learn about the what done by a single processor. So we know the processor. But concept is a cache based microprocessor architecture. So just look out this diagram. Concentrate on this one. This is a main memory. This will be a main memory. Whatever your processor or system will be have. Then it is go to the memory interface. So we interface the memory with our different processor or controlling unit. So just look out here. L2 unified cache, that is a cache. There is a cache-based memory. L1 instruction, that is an instruction cache. Here L1 data cache, right? Just look out what I show. So first what we do, the main memory is interface with a number of peripherals or a number of devices, whatever you use in your CPU, central processing unit. Here, L2 is one of that unified cache. L1 is a instruction cache, and also L1 is a data cache. So, what is a cache based on microprocessor? That concept will need to be understand. Then it go to the input. Then it is a integer oblique floating point q. Just look out integer oblique floating point q. Next memory q. Then floating point register file. Then integer register file. Then floating point add. Floating point multiplication. Then st. Then ld. Then instruction. Then shift mask. Is it clear? Just I clarify the diagram. What parameter will be added? So I explain what is the meaning of cache-based microprocessor. So a general purpose cache-based microprocessor architecture is a design that uh, incorporate incorporate the cache memory to enhance the performance of just look out to enhance the performance of central processing unit. Why we use the cache-based processor? To enhancing the performance of central processing unit. That is the CPU. To enhance the performance of central processing unit in handling various computational tasks. Just look out, it is a very important in handling various computational tasks. So what are the tasks? We have a number of tasks. It's like that arithmetic and logical is one of the tasks, right? That will be do the addition, subtraction, multiplication. That is a number of parameter will be a consider, which handle the cache. So how the cache memory to enhance the performance of central processing memory. Now, just we considering that suppose your system, whatever your laptop is a suppose having a RAM, random access memory with a 2 GB RAM, right? And you execute the number of programs simultaneously. So what will be that all program work, but with slowly it will be work, and it require more time to be a execution. But if I increase the 2 GB RAM to the 4 GB RAM, what will be happen? Can anyone guess? What will be happen if I increase the RAM capacity from 2 GB to the 4 GB? What will be happen? Can anyone? Can anyone? What will be happen if I increase the capacity of RAM 2 GB to the 4 GB or suppose 8 GB? What will be happen?
सर प्रोसेसिंगची स्पीड वाढेल थोडीशी.
Execution of speed of processing will be increased, meaning that whatever the four program previously you work, they require suppose 10 minutes for execution, it require only 5 minutes, right? So execution speed will be increased. Same time same way we try to execute, so more time we collect the data, then process the data and give the output to the data. So main of the data, the memory having more load. If I support some of the extra memory to the memory, so execution will be increasing. Same thing will be a do here. Same thing will be a doing here. The cache-based microprocessor each one of the memory which help to execute the number of program fastly. It provides some support, additional support to the memory to execute the number of program by adding the number of memory parameter. Is like same like 2 GB RAM is replaced by 4 GB RAM or 8 GB RAM. So execution of number of instruction or number of program will be fastly compared to the previously. The load of memory will be a reduces. The load of processor will be a reduces. Same way we trying here with adding a cache based microprocessor. So what we the enhancing the performance of central processing unit in handling various computer tasks. Suppose we doing with a arithmetic operation or some of the instruction which having the two type of data. One is related with a integer type of data and second is related with a floating point of data. So we do the separate of processing. Integer type we doing separately and floating type we different separately and executed simultaneously. So both output will be occurs at a same time. Both output will be occurs at the same time. So what we do, the cache memory is a small size. It is a small size. Just look out. High speed type of volatile computer memory. What is this one? It is a volatile memory. Just like a RAM. 2 GB RAM is replaced by 4 GB RAM. So what we increase the memory of RAM, right? So execution process will be a increase. So cache memory is a small size, high speed type of volatile computer memory that provides high speed data access, which can access the high speed data from the memory for a execution of that work to a processor and store frequently use a computer program. Store frequently processing and store the frequently use a computer processor and store the frequently use a computer program. So application and data, just a second. I 1 minute. Okay, it is a time limit of Zoom. I repeatedly again send the link. Huh?